DM water system. This lecture is part of the lecture series on steam power plant systems. It may be useful for plant operating staff. This is a typical flow diagram of DM water system. The same diagram as shown in previous slide, but little bigger in size for your convenience. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. DM water system. The DM, that is demineralized water system, primarily meets the heat cycle makeup water demand to replenish losses from the blowdown of the boiler drum, leakages from valve glands and flange joints, steam venting, safety valve popping, etc. Clarified water into demineralized water. There are various methods of treating clarified water into demineralized water. The common feature of each method is some form of ion exchange process, that is, displacement of one ion by another. Demineralized water coming out of the treatment plant is stored in DM water storage tank. Raw water, irrespective of its source, contains many minerals as cations, that is, positively charged ions, and anions, that is, negatively charged ions, in diverse concentrations, along with silica, that is SiO2, and free carbon dioxide, that is CO2. Cations in raw water are usually calcium, magnesium, barium, aluminium, iron, sodium, and potassium. Anions generally are chlorides, sulfates, nitrates, carbonates, and bicarbonates. In an ion exchange process, cations are replaced with hydrogen ions in a cation exchanger, and anions are replaced with hydroxide ions in an anion exchanger. Resins generally used in an ion exchange process are weak acid cation resin, strong acid cation resin, weak base anion resin, and strong base anion resin. The amount of resins needed in a plant depends on the quality of incoming water. A weak acid cation unit exchanges cations of mainly alkaline salts, that is, carbonates, bicarbonates of sodium and potassium. If the cation content constituting bicarbonates is significant, the incoming clarified water is first passed through a weak acid cation unit. If the incoming clarified water contains cations of both neutral salts, that is, chlorides, sulfates, nitrates of calcium, magnesium, and sodium, and alkaline salts, they are exchanged with the hydrogen ions of the resin of a strong acid cation exchanger. The effluent of strong acid cation exchanger is usually called decationized water. This water then enters the degasser tower, where CO2 is removed by scrubbing with an upward flow of air. The outgoing effluent from the degasser tower is called decationized and decarbonated water. The use of a strong base anion unit exchanger is required in the event that incoming clarified water contains anions of both strong and weak acids, that is, hydrochloric, sulfuric, nitric, carbonic, and silicic, to exchange them with free to move hydroxide ions of the resin. In plants where free mineral and ionic content of clarified water constitutes a large amount of the total and ionic content, then the incoming decationized and decarbonated water is first passed through a weak base anion exchanger. This exchanger removes by absorption only the mineral acids that are strong acid molecules of hydrochloric, sulfuric, and nitric acids. Water coming out of a strong base anion unit is demineralized water containing very minor dissolved compounds. These remaining impurities are then polished in a mixed bed unit where both cation and anion reagents are mixed. In general, various vessels which contained chemicals and resins used for DM water production comprise pressure sand filter PSF, activated carbon filter ACF, weak acid cation unit WAC, strong acid cation unit SAC, degasser, weak base anion unit WBA, strong base anion unit SBA, and mixed bed unit MB. Figure shows the arrangement of various vessels without WAC, weak acid cation, and WBA, weak base anion units. Water enters each vessel at the top, flows downward through the filter media oblique resin bed, and then flows out of the bottom of each vessel. In the pressure sand filter PSF, turbidity of incoming water is reduced. PSF is followed by the activated carbon filter ACF, where suspended impurities and organic matters are entrapped and free chlorine and free iron are removed. Flow of water is downward as explained earlier. Once all available ions in an ion exchanger become saturated and exhausted by repeated exchange of ions, the exchanger is regenerated. Regeneration of SAC and also WAC, if provided, is carried out with hydrochloric acid, whereas SBA and also WBA, if provided, is regenerated with sodium hydroxide. The process of regeneration is classified as co-current when chemicals hydrochloric acid and sodium hydroxide are dosed along with the flow of water. The process of regeneration is classified as counter current when chemicals are dosed in the reverse direction of flow of water. Figure depicts the condition of the resin bed of a typical strong acid cation exchanger before co-current regeneration. Figure depicts the condition of the resin bed of a typical strong acid cation exchanger after co-current regeneration. In this slide, the diagrams shown in previous two slides are shown together for ease of comparison. The condition of the resin bed of a typical strong base anion exchanger before co-current regeneration is shown in figure. The condition of the resin bed of a typical strong base anion exchanger after co-current regeneration is shown in the figure. The diagrams shown in previous two slides are shown together in this slide for ease of comparison. In this slide, we have shown the table which depicts the quality of demineralized water downstream of mixed bed usually. Electrical deionization unit EDI. In plants where the requirement of demineralized water is not substantial, the treatment of clarified water uses an electrical deionization unit EDI based on membrane technology. The EDI process removes ionizable species from liquids using electrically active media where an electrical potential influences ion transport. These units ensure continuous water purification without regeneration of chemicals. EDI based plants comprise cation exchange membranes, anion exchange membranes, spacers, electrodes, and cation/anion exchange resin. The primary cation/anion exchange process is replaced with a reverse osmosis process. It is the initial demineralization step that removes ionic impurities, particles, and high molecular weight organics. EDI replaces the mixed bed ion exchanger. It is the final demineralization step that removes residual ionic and ionizable impurities. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel.